Part 2. Preface to the Mathematics of Semantic Meaning. In my introductory video, I expressed the sentiment that I think of myself as fortuitous for not being encumbered by a formal education in philosophy or linguistics. I stand by this comment as far as the ability to conceptualize a theory of evolution beyond the limitations of evolutionary biology is concerned. In almost every other respect, however, I have to point out this lack as a deficit worth mentioning, especially as this video is meant as an introduction into the mathematics of language, knowledge, reason and the nature of the origin question. In this video, I will primarily discuss some of the problems and expectations related to the quantification of language. Towards the end of this video, I will introduce one very basic mathematical aspect of language, which, by the way, is already well established and yet gravely underrepresented in linguistic theory as well as philosophical thought. Rather than immediately moving on to the next clip of the series, I really urge you to reflect on this little snippet of information. Before we can take a closer look at the mathematics of language, I will have to establish a method to quantify and/or algebraize semantic meaning. According to a lecturer in linguistics and computer linguistics, this cannot be done. A lecturer in natural philosophy even asked why I would try to do this. Disregarding this professional bias, disbelief and/or just plain skepticism for the moment, we will have to set the bar regarding a successful argument high, not just reasonably high, but very high. A method to quantify semantic meaning has to meet an extensive set of requirements, and only a fraction of these requirements are related to linguistics at all. In the first instance, though, these are mainly linguistic in origin. Examples for questions related to the quantification of language are: how is language different from non-human communication? What is the origin and prehistory of the human language? Why and how does language and meaning evolve over time? How did syntax evolve? How does language relate to cognitive and pre-neurological processes? Do all languages share universal properties? Can we pinpoint specific co-evolutive factors between the emergence of language and the evolution of the brain and vocal cords? And although questions like the following might seem superfluous to non-linguists, even: what is a word? What is a sentence? How do words and sentences logically and mathematically relate to each other? Can the supposed mathematical structure of meaning and language account for the dynamics of philosophical debates as well as everyday communication? And while the method to quantify language and semantic meaning does not specifically address even one of those questions, it has to account for a solution to all of these and related problems of linguistics, philosophy, and cybernetics. Then, of course, there are the questions of a more philosophical, that is, epistemological and ontological, and in some respect even metaphysical nature. For example, what is truth? What is beauty? What are morals? What is society? What is life? What is anything? While the method to quantify semantic meaning does not, and cannot possibly, answer even one of those questions in absolute terms, it has to provide an understanding and methodology, how to address any of these questions in approximative terms. At last, there are questions which are so far removed from any specific scientific problem as to approach empirical science from the other side. For example, can our understanding of the world beyond our immediate sensual perceptions, and thus the evolutionary progress of the accumulation and differentiation of science and knowledge, be quantified? Before moving on to the more entertaining task of breaking down language with numbers, I'd like to engage you in an experiment that will serve as common ground for the next video, in which I will have to account for the basic mathematical properties of language. The following exercise will focus on the difficulties in trying to establish a consensus by defining anything, be it a concept, a process, or an object, real or imaginary. The point of this exercise is to focus on the process of quantification and the means available. If you are indeed a student or lecturer in philosophy, logics and/or linguistics, I cannot help the possibility that much of what follows is already known to you, especially if you know the history of term logic and the goals, achievements and failings of George Boole. Instead of immediately aiming at algebraic logic, this approach will primarily focus on the consolidation of a non-genetic and highly self-referential information system within the realm and limitations of living organisms, that is, human beings. The algebraization of language is a byproduct of this approach. Imagine or focus on an object, an idea, or a complex philosophical concept. For the moment, however, I advise you to pick a fairly common object, for example anything you can point your finger at. Now, try to define the nature or essence of that object, that is to say, try to define the set to which this object belongs to in as few words as possible, disregarding any syntactical and grammatical rules for the moment. You will be left with an enumeration of n-qualities, which are specific to your cognitive representation of the world and thus at least somewhat individual to the cognitive processes by which you subconsciously pre-order the world beyond your immediate perception and prior to any subsequent process of communication, at this particular time and in this particular context. Focus on a similar, yet originally excluded, item and try to include this item within the set you have previously defined. Focus on a dissimilar item and try to include this item within the set you have defined. Account for any discrepancies or cognitive dissonances between the second, third, fourth, fifth item and the previously defined set by assigning the number 2,